channel. In this video, I'm going to show you SPM Form 5, Chapter 7, Probability. So, before you can really start off with, you need to understand what does it mean by random sample. If it were to be random, normally it happens in random, meaning if it were to be random, it means that the outcome of any event are supposed to be equal. Outcome is equal. Is equally occur. I mean, the possibility that it will occur is equal. Okay, it is not biased to certain criteria. Say you want to roll a dice, the outcome for getting 3. If it were to be a fair, I mean, the dice is random, the possibility is 1/6. Now, how I'm going to represent it? You may want to visualize it in a Venn diagram. Venn diagram, I mean, it's a sample size. For any event, maybe I'll label it as a big circle, and possibility of getting whatever here, I'll name as B. Maybe this is a B. This is my sample S, sample size S. So the possibility of getting B, so the possibility of getting my event is B. Possibility of getting B would therefore be the number of B over the total number of S. Okay, so let me give you an example. What does it mean by that? I'm sure you can understand what does it mean. Say you want to roll a dice. And you are asked to find a possibility of getting 2, 4, 6 even number. So to start with, first of all, you list out what's the possible outcome for sample size. For sample size, therefore, would be 1, 2, 3, 4, 5, 6. Sample size is 6. So therefore, my number of sample is therefore 6, the size, number of size of the sample. But if you want to find the event, let's say my event A, a defined event A is even number, it's 2, 4, 6. Therefore, my event size is 1, 2, 3. 3 number. So therefore, my possibility of getting event A is therefore 3/6, which is half the possibility. Okay, it's quite straightforward. It's very similar to your modern maths. In SPM, there's a modern mathematics and additional maths. So this chapter is somehow it's actually the same with some new terms, of course. Now, next thing that you want to learn is called complement. Complement of an event A prime. We name this symbol as prime. So how do you find it? You want to prove, the number for whatever outside, meaning it's outside of this, if it were to be A outside of it, is therefore number of the total sample subtract with number of the event A. So if you want to find out the possibility, so the number, anything outside of the sample, over the total sample is therefore equals to, this is NS over NS, this is number of A over number of sample, and therefore this would be the possibility of for A is actually 1 subtract possibility for A. So if you want to find out whatever outside of an event, all you can do is use 1 subtract with the possibility of the event. Okay, so this is is to this is the second thing that you will learn, complement. Now, what happened if now there are two events? How to find out? For two events. Okay. Now, probability of two events are simply you were able to represent by using a tree diagram. Okay, I think the tip is not sensitive anymore after some time of using. Yeah. So, say for a tree diagram, you will get says you will get a question like I have one box A. Says you have box A. Inside of box A, you have number 3, 5, and 6. And box B, you have number like 1, 2, 5, and 6. So in this question, box A and B, they are mutually exclusive. They are not mutually exclusive. They are not mutually exclusive because 5 and 6, 5 and 6, they are the same number. 5 and 6, they are 5 and 6 in box A. They are also 5 and 6 in box B. Okay, a ball label with this number. So they are not mutually exclusive because they have the same number. They are not independent. Now, so what happened is, if I want to find out what's the possibility that you will get by the end of you get one ball from box A and one ball from box B, what's the possibility that the two numbers are the same number? Okay, so how are we going to do that? There are a few ways of doing it. First way is by using a tree diagram. So that would be the first trial with 3. This is 5. And this is 6. If you get ball 3, then next term will be 3, 4, 1, 2, 5, 6. This is box B. 1, 2, 3, 4, 1, 2, 5, 6. 1, 2, 3, 4, 1, 2, 5, 6. Right? So in every branches, yeah, says for the first box, this is where the box A, the possibility of getting either one of it is 1/3. 1/3. 1/3. And 1/3. In box B, the possibility of getting 1 is each of the ball is 1/4. 1/4. 1/4. 1/4. But the outcome would be this is 3 and 1. This is 3. This is 1. This is 3. This is 2. This is 3. This is 5. This is 3. This is 6. And then this is 5. This is 1. It would be quite tedious if the list gets longer. But for this example, it is manageable. Okay, 6, 1, 6, 2. This is 6, 5, and this is 6, 6. Okay, quite tedious because I want to understand what's happening. So the possibility of getting same number will be therefore, say, okay, now I want to find out what's the possibility. My event, I want it to be 2 balls are the same. Okay, 2 balls are the same. Okay, so you want to find out 2 balls are the same. So first of all, you will need to look through the list. No, so this will be here 1 only. Is it 1 only? 3, 5, 6. Where is my 6, 6, 6? Oh, okay. I accidentally, okay, I make a mistake over here, sorry, overlook it, okay, I double check on it. This is 6 and 6, okay, so 1 and 2, these two number, they're the same. So now what's the possibility of getting this and here? So this 1 3, and in order to get 5, this 1 4, isn't it? In box B, you look at here, the possibility of getting 5 is 1 over 4. The same goes here, is 1 4. So the possibility of get 5 and then 5 is 1 over 3 and then 1 over 4. And the possibility of getting this is 1 over 3 for second 6 and 1 over 4, you times them. So this is 1 over 12, this is 1 over 12. Okay? So therefore, possibility of getting the same number is equals to 1 over 12 or 1 over 12. This one 5 5 and 6 6. Therefore is 2 over 12. This will go 1 over 6. Okay? And there are actually 12 outcomes. 1, 2, 3, 4. 4 times 3 is 12. 12 outcomes. There are 2 of them at the same. This is how you normally do it. And you may they will sum up the sum of the two number is more than 5. Then you find out which one, how many out of 12. So simple and quite straightforward in this sense. Okay, so this is one of example where they are not mutually exclusive. Not mutually exclusive because this number A and B, they are independently the same. I mean, they are mutually independent, so it's not mutually exclusive. Now what happened for the case that they are mutually exclusive? Mutually exclusive. Exclusive meaning they are special, meaning they are not, meaning that they do not depend on each other. If you have a Venn diagram, simply you may be able to represent it easily, where I will have my sample size S. Maybe I have my number of A is here, and then number of B is here. So A and B, they do not overlap with each other. Mutually exclusive meaning A and B is 0. So here it will be possibility of A or B. If you want to find out the possibility of A union B, A or B, therefore that will be n number of A union B or B over total number of the sample. Okay, and in order to really represent it mathematically, so number of A union B, A or B, is actually number of A plus number of B, and remember to subtract number of A and B. Okay? Because sometimes in some cases A and B might be overlapping. So you divide it with number of sample on both sides. So therefore the possibility for A and B is actually the possibility for A and B subtract possibility of A and B. In the event, for this case, if A and B they are mutually exclusive, you find that the number for A and B is actually 0 or 0. So in this case, therefore possibility of A and B is equal to 0. If they are mutually exclusive, A and B is 0, therefore you left with only if it were to be A and B, so all you need to do is PA plus PB. Okay? Unless they are not mutually exclusive, meaning they overlap. The Venn diagram, if you were to have sample size S, is where you need to look at, and you have sample A and B, the intercept here, B, and this is A. Then this case, yes, the possibility of looking for where they overlap, A and B would therefore be the number of A and B over the total number of the sample, and possibility of A and B is actually equals to possibility of A times possibility of B. Okay, we should be able to prove it. Just break out the equation. So let me give you an example, because it's so theoretical, you might find it hard to understand. Maybe I'll show you a few examples and you'll be able to excel on this chapter. And normally this chapter requires the previous chapter, chapter 6, permutation and placement. Okay, so let me give an example, short one maybe. Example 1. Okay, again, maybe you have a box. Okay, inside a box, you are given a box. The question form is summarized in the graphic. You have about 10 books, so the sample size is 10. Okay, so in this over 10 books, there are 1 book in Japanese, maybe 2 books written in French, and another in other languages. No, 1, 2, 2 plus 1, 3. Then 7, sorry. The rest is others languages. That doesn't really specify what language. Okay. So now, if in the event that you need to choose 5 books randomly, you were asked to find what is the possibility of getting 1 Japanese, 1 French, and 3 others languages. Okay. So for this question, first of all, you need to choose. So the keyword is choose. Okay. Now in order to choose, based on this criteria, out of 5 books, so your number of the event would therefore be Oh, before the number event, let's look at number of sample. That's standard operation procedure. So first of all, find out the sample size. So the sample size, you have 10 books, you choose 5 books from it. So therefore, it's 252. You have watched my previous video, chapter 6, from 5 chapter 6. Maybe you would look at it, how do you get this number from here, and what does it mean by C? And in order to find the event based on this criteria, what do I have? Out of one book, there's only one book here, and you choose one. And 2 French books, you choose one. And 7 others, you choose 3. So therefore, times in, you get 70. Okay. So therefore, possibility of 1 Japanese, 1 French, 3 others. So therefore, 70 over 252. And now, of course, you may simplify this number. If you simplify it further, it's 5 over 18. Quite easily done. Okay. So there are questions. For example, next question. And okay, exercise 2, example 2. So you have 1, 2, 3, 4, 5, 6, 5 object, 5, 6, 15, 4, 2, and 12. They have 6 cards. 1 card is chosen at random. So 6 card. Oh, you can't really do that because you need to find a possibility. Okay, possibility that the number chosen, of the 1 card number chosen is a multiple of 3 and factor for 24. Okay. So for this case, the keyword is n. You find that this A and B, factor of 3 and factor of 24, they are overlapping. So you might use the union, sorry, not union, exclusive, n. Right? So, say for example, over the 6 card, I have 2 A and B. Number for A will be multiplied by 3, that will be 3, 15, 12. Right? Oh no, sorry, it's a 6, 15, 12. And factor for 24, however, factor of 24 would be 6 and 12, isn't it? No, and also 4. Yeah, miss out. It's 3. 1, 2, 3, 24, 2 also, 24. Okay, so how am I going to do that? Yeah, I think straight away I'll get into the point, head to the point. So therefore, they are overlapping. Okay, this and this is not mutually exclusive, so therefore my A and B would be therefore equals to number of A and B over number of total sample. So here number of A and B is the overlap, meaning here the overlap, here the overlap. So there are only 2 out of the total number is 1, 2, 3, 4, 5, 6. 6 cards. And therefore the answer is 1 over 3. Okay? So it's example part 1. Maybe part 2 they say find me the possibility, find me a possibility so that it is a prime number or an even number. Okay, so the keyword given is or, a prime number or even number, but you can't straight away get into the answer because you can't really get the answer. So all you need to do is what you need to do for yourself, you release the number. Okay, maybe I list it out in terms of set form. Let's say A is my prime number. So what are my prime number? So you want to find a prime number would be 2, 3, 4, 2, 5. Then the rest is not, prime number. Whereas my event B is an even number. Even number would be 2, 4, 6, and 12 in ascending order. Okay. All right. So if it were to be OR, you'll find that they are overlapping. So you do not calculate it has to be 6, because if it were to be OR, it will be possibility C. No. This is question 2 already. Okay. So event A or B, you need to subtract off one of it. It's 1, right? So there's 1, 2, 3, 4, 5, 6. Instead of writing 6, that's only actually 5, because it's 2 plus 2 plus 4. Subtract one of it, right? Because 2 and 2 overlap. You need to subtract. Okay? Over the total number of cards is 6, total number size 6. So therefore it's 5 over 6. Okay? Why is this subtract 1? Because if it were to be OR, and it's also one of them is overlapping. Here is calculate 2 already. 1, 2, 3, 4, 5, 6 up to 6. But 2 and 2 is the same number, so you need to subtract off 1 of it. Right? You don't subtract 2, you subtract 1. You subtract 1, then you don't calculate 2 anymore. So you don't get an answer. Right? This is how you use it, mutually exclusive. Right? So maybe I'll give you an example. Maybe one last example. Or maybe I'll give you some exclusive. Say maybe a mutually exclusive questions. 1, 2, 3. Maybe you have a bag. In this bag, there are 3 red balls, 2 blue balls, and this is sample size. you need to choose or pick 3 balls. Pick 3 balls at random, and you're asked to find possibility that 2 red balls and 1 blue, or 1 red ball and 2 blue balls. Okay, so this is a question that sounds very complicated. So first of all, let's find out, okay, the possibility or the sample size, the sample space, the NS sample space. So here, 5 balls, I'm going to choose 3 from 5 balls. So therefore it's 10. Okay, then find out the first one. This is my event A, and this is my event B, maybe. Okay, so find out my event A. What's the sample size for A? Okay, in order to get 2 red and 1 blue, so 2 red. So out of 3 red balls, I choose 2, and out of 2 blue, I choose 1, and therefore that will be equal to 6. Okay, from calculator. And how about for sample size for B? That would be 1 red ball. That would be 3 red. I choose 1, and 2 blue. I would choose 2. So therefore, the sample size will be 3. Okay. So I define the sample size. I define event A, define event B. Then I'm quite fit to go. So therefore, my answer for the possibility for this event, 2 red and 1 blue, or 1 red and 2 blue, the possibility would be therefore 6 over 10 for the first one, or it would be plus 3 over 10. That would be contribute to 9 over 10. Okay, so now this is example. This is example where event A and B are mutually exclusive. Okay, they are mutually exclusive because A and B, they do not really interact. Because A, you know that A and B is actually 0. Okay, because of that, you're able to use it. Because you know it's 2 red, 1 blue, 1 red, 2 blues. Okay. Now, let me give you another example. In contrast, put into side by side so that you're able to compare them. This is on the left, mutually exclusive. On the right, is not, mutually exclusive. So how you do is you're given 2 events. The event possibility of getting A is 1 over 5. Possibility of getting B is 3 over 5, 3 over 4, sorry. Possibility A union B is actually 1 over 4. So you asked to find the possibility of A and B. So this is something the concept base. So if you want to really find A and B to see if it's 0 or not, what you do is start out with the standard equation. That would be a possibility of A. If you remember the possibility of B, subtract possibility of A and B. Okay. So therefore you bring it over. Possibility of A and B. Therefore B. PA is 105. PB is 305. A and B bring over, subtract 104. It seems that it's 7 over 10. So therefore A, you may write A and B is not 0, and therefore A and B, they are not mutually exclusive. Therefore UN A and UN B, they are not mutually exclusive. More mutually exclusive events, meaning they will have overlap. A and B, they are independent. Okay. I think that's all about it. I mean, I will not be able to try out every single questions with you, but this is something that you need if you get along with those theory. My advice to you is always the same. For probability, this chapter, you might need to at least try 30 questions. At least 30 questions. Okay, for mutually exclusive, mutually not exclusive, and proving of equation. Okay, you might need use of the C combination and permutation, but normally it's a combination. They don't have much of permutation. You might need a week time maybe, to have at least a week time to get yourself familiarized with this chapter. You might at least spend 30 questions over a week, 7 days, before you proceed to the next chapter. Okay, that's all from me in this chapter. It's quite short. I hope you will do well in your exam, and if it is good, you like this video, do press on thumbs up button. This is what I will ask you to do. It costs you nothing. It means that you like my video and encourage me to make more video in future. I wish you good luck. Stay tuned to my YouTube channel. Thank you.